this is another code, and I'm going to be using it uh, to once again just find interference patterns, because that's what we use this for, right? And okay, so let's explain this. This R thing, and yeah, this is basically for the double slit experiment. So if you want to read on that, first read that and then come to this video so that you will understand this better. So this R thing, this is how far away we are from the slits. This X naught thing, this is the distance between the slits, and actually half the distance between the slits, I think. Okay, this N is just like how many times do you want to iterate the thing, how many times, how many wave fronts do you want from each point. Yes, this is the wavelength, so I've set it to 0.3 for now, and then this is the code that will do the thing. And I'm also going to graph this line at y equal to 52. Okay, so that will help us understand what's happening for a wall or something. Yeah, so what's the thing that we are really going to see. Okay, so let's run this. So as you can see, this is an interference pattern, and uh, the fringes or the bands or whatever they're called, those things are very far away, right? They are spaced apart. And what happens if I try to change some stuff, if I try to change the wavelength or the x naught value or something like that? Let's see. So let's change the wavelength first. So if I increase the wavelength, right, this thing happens. You don't see any noticeable change right now, but soon enough it will become clear what's happening. 0.5. So as you can see that the number of whatever that thing is called, the fringes thing, right, those are decreasing in this area. So let's set the wavelength to 1, and yeah, this is what really happens. So now you just have one maxima over there, and yeah, everything else is just like plain, because it's not a maxima or anything. So yeah, that's nice. And what happens if I decrease the wavelength? So first it was 0.3, right? So we had this kind of pattern, and let's set it to 0.2. So as you can see that there are more number of fringes over there, and the width between the fringes, so the width of the fringes, I don't know, the width between the maxima and minimas, they have decreased. Okay, cool. And let's also see what happens when you change the distance between the 2 points. So right now we have 0.5 as a distance. Let's set it to 1. So as you can see, there's more interference, and that's why you have more number of these maxima minima things. Cool. Let's give it even a higher number. So x not equal to 2. Yeah, this is more and more prominent now, that there will be more and more interference. The maxima minima, those things will be more visible, right, because they are smaller and more compact. Okay, cool. And then let's kind of decrease this. So let's set it to 0.1. Just hope it doesn't crash. Yeah, so this is completely gone. So this distance, it kind of plays a huge role, right? It's affecting it much more than what this wavelength thing did, and there's a reason for that, because this distance is going to be in the denominator of the equation that you will get for the width of the fringes. So that's nice. And let's try to set it to 0 and see. Well, I mean, okay, that's stupid, because we know when it's 0, yeah, it just gives it gives no interference. So 0.1 was nice. Let's set this to 1, right? So you can see this is going nice, and let's set it to something really high, maybe like 10. Yeah, so now the interference is not very visible. It is there, but it's more like a matte kind of thing, right? And not really lines over there. So this is becoming like a little different than what we thought it would be. There's still interference, yeah, but it's not the way that we wanted. So I mean, over there you will have like thousands of small maxima minima things, but at the same time you also have interference in, what do we call it, like you have it in 2 dimensions, not just one, right? I mean the visible thing, that will be in 2 dimensions, and it will be much more complicated. So that's for x not equal to, let's check for x not equal to 5 as well. Yeah, so it's somewhere in between. Okay, anyway, so that's really nice. That's all I wanted to explain. So yeah, see you later.